Okay, hello. In this video, we're going to look at a number of different functions, very common functions that you need to know. So you're going to want to be able to recognize these functions and identify things about them. And we'll just go through each one. This paper, 3.4, is given in Blackboard under the video link. So you can print out this sheet if you have a printer. Otherwise, you can write this all on your own piece of paper. That would be fine too. But it'd probably be a little easier if you can print out the paper. So we're looking right now at 3.4 Library of Functions. Yes, this is section 2.1, but this is where I want us to get familiar with these functions. All right, so the first function, notice that the functions are drawn here in red. So this is just a horizontal line, and that is called the constant function. And the equation for the constant function is y equals some number b. Okay, notice that in this case it's like y equals, well, there's 2, so it's actually less than 2, but maybe more than 1. But you can't exactly tell. So y equals b. And notice that that's just a horizontal line. Okay. The second function is called a line or the linear function. Okay. That function, the basic function of it is just y equals x. Okay, notice that the function goes through the point 0, 0. That's its x and y intercept. Okay, notice that it has that slope of 1. It goes, in other words, it goes up 1 and then to the right 1. Up 1, right 1, consistently. Okay. Um, the third function is called the squaring function. Okay, that's what you get when you take y equals x squared. Okay, and I probably should be pointing out some of the key points on these graphs, so I'll do that now. So notice that this graph, one key point would be 0, 0. Another key point would be 1, 1. And another key point would be -1, -1. Okay, obviously with a line it's not too crucial, it's pretty easy. Here over in the squaring function, notice that we still have that intercept of 0, 0. And then here is our point 1, comma 1. And then over here is our point -1, comma -1. Now, if you really want to graph a squared function well, you probably want 2 more points. So notice that you have a point here. That point would be 2, comma 4, because when you put in 2 for x, square it, you get 4. And over here, when you put in -2 for x and you square it, you also get +4. So that's right here. Notice that we have a symmetry going on here. So something to know about the squared function or squaring function is that it is symmetric about this y-axis, right? So it's symmetric about the y-axis. Notice when you go back to that linear function, okay, that actually is symmetric as well, but remember when it's in the diagonal quadrants 1 and 3 or 2 and 4, then that is symmetric about the origin. Okay. What kind of symmetry does the constant function have? Okay, does it have any symmetry? Yes, it does. It is also symmetric about the y-axis. Okay, so up here in green, I wrote what the symmetry was for each of those functions. There are other things that you could look into about these functions, such as you should probably figure out what their domain and range is. You could figure out where they are increasing or where they are decreasing, etc. All right, so let's move on to some more functions. See if I can't get the page to go down there. All right. So to look at 3 more functions, we now have the this function that starts down in the 3rd quadrant and increases into that first quadrant with that curve, that is called the cubing function or the cube function, and that is y equals x cubed. Okay. Notice that once again, that is symmetric about the origin. So you might want to mention that its symmetry is about the origin. And then we also want to write those key points in. So in this graph, you start there at 0, 0. Okay, and then you do have a point here at 1, 1, and you do have a point here at -1, -1. All right, the next function only is right here. Its only domain is only positive, its range is only positive, okay, and this is the square root function. The square root function's equation is y equals the square root of x. Okay, that's why there's no values down here. If you try to put in the square root of -4, you do get an imaginary number which does not graph on the real graph. So you're only going to put in 0 and up on this one. So let's actually mark that down, right? We notice on this one it has a special domain of 0 to infinity. Okay, the bracket telling us, yes, you can take the square root of 0, it is 0. And then the range also being 0 to infinity. Okay, the key points on this graph, right here, 0, 0. Okay, we also have that nice point at 1, 1. Okay, we really don't have a good point at 2 because the square root of 2 is not a whole number. So we'd have to go over here a little bit farther to put in 4 for x to get 2 for y. So that third point that you want to graph is 4, 2. Doesn't fit on this graph. And then finally, the symmetry. What kind of symmetry does this graph have? That's right, it has no symmetry. Okay. All right, so the last one on this page right here is very similar to the cube function, but notice how it's turned on its side, kind of like that root function, the square root function. That's because it is the cube root function. Okay, cube root. And that equation is y equals the cube root of x. Okay, notice that the cube root, you actually can take the cube root of a negative number and get a real negative number. That is okay. So we don't have a domain restriction. So our points are 0, 0, 1, 1, and -1, -1. Notice that, this equation, it goes uphill quickly like this. And then this equation, although it has the same 3 key points, it definitely does not end up looking the same as the other graph. All right, and it does have symmetry, right? It does have, again, symmetry about the origin. All right. The last 3 graphs we're going to look at, okay, are right here. So first, looking at this graph, there's actually 2 parts to this graph, and they are symmetric right there. And the first of those graphs, that function is called the reciprocal function. Reciprocal function. The equation for that is y equals 1 over x. Y equals 1 over x. So this is a pretty special function. We're going to study it later in the semester. Reciprocal functions and rational functions, they're all going to kind of look like this. A special feature of these functions, to be able to graph them, you need to know that this function has what's called a horizontal asymptote. And that asymptote is a line that the graph gets closer and closer to, but never actually touches. Okay, so this graph here is heading towards this line at y equals 0, but it never crosses, it never goes below y equals 0. Same here. It's going up. It's getting closer and closer to y equals 0, but it never gets there. Likewise, this graph also has a vertical asymptote at x equals 0. So this is also called an asymptote. I am spelling that right, so it's A-S-Y-M-P-T-O-T, asymptote, and this is called a vertical asymptote. This one occurs, what that means is that the graph never actually equals x equals 0, okay? This side of the graph never touches x equals 0. This side of the graph never touches x equals 0. See if you can think about y from the equation, right? 1 divided by 0. Uh-oh, right? So that won't work, and that's what creates that vertical asymptote, okay? So when we talked about the domain on some of those others, I think it might be nice to talk about here, right? The domain of this graph, okay, you do start over in the left at negative infinity. You go to 0, but don't include the 0, and then finish up with 0 to infinity. That just takes out that 0 because x can never be 0. The range is actually exactly the same because it also takes out y equals 0. So negative infinity to 0 and 0 to infinity. All right. We only got, so let's talk about, before we move on, we better say what the symmetry is. Notice that it has that diagonal symmetry across the origin, so it is symmetric around the origin. Okay, and then finally, two more. We have this V graph. It's a hard V. This is called the absolute value function. And the equation is y equals the absolute value of x. Okay, that's the one that's pretty used pretty commonly. Here we have the points 0, 0, the point 1, 1, and the point negative 1 comma 1, very similar to the on the front, the y equals x squared, except there's straight lines there. Okay, so like y equals x squared, this also is symmetric about the right there, the y-axis symmetry. Okay, and then finally we have this really weird function that's made up of a bunch of different pieces, and this is called the greatest integer function. Your book uses this one a bit, but we really don't study it a lot, so I don't want to spend too much time on it, except to say that the graph here is a little bit inaccurate. So what's happening is this point is included, but then this point is an open circle, not included, for every single one of these. Otherwise, it wouldn't be a function if both ends of the graph were included, because it would, overlap in those y values. For an x, there wouldn't be just one single y value. Okay, so the greatest integer function, and the equation for that one is y equals int of x. Okay, and I think that's all we're going to say about that one because we don't really use it a lot in our further studies. All right, thanks for joining me. See you soon.